Okay, this video is about more thoughts on amyloid and dementia. And basically, this is stuff that didn't either fit into the other talks or maybe I forgot to say it. Plus, I did more reading. What I'm basically doing is I'm trying to figure out how to connect everything with regard to neurodegeneration. It's all over the place in the textbook. It's all over the place in the published papers. But I'm basically seeing the pattern. And I gave you my theory before. What it really comes down to is, do you have good oxygen and glucose delivery? Are you avoiding toxins? And are you avoiding stimulants? Because the stimulants ramp up metabolic demand. They're basically like a metabolic toxin. Metabolic toxin decreases your ability to produce energy, so that is a problem in meeting energy delivery to energy demand. And a stimulant does something similar in a sense. It ramps up metabolic demand for no good reason, which is about like taking energy away from you. Okay, and it can cause excitotoxicity. So anyways, just a couple thoughts on dementia. First of all, we talked about sleep in the previous lecture about the glymphatic clearance. Some persons have asked me, when is it most important? It's during deep sleep. That's when the neurons can go most offline. They're still a little bit busy during REM sleep. And it's been confirmed in humans in several different ways, the glymphatic system's existence in humans and function in humans. Beta amyloid, all those theories, they're not as helpful as, obviously, vascular dementia is far more important than this beta amyloid stuff. But beta amyloid is relevant. But it's kind of simple. We're going to talk more and make sense of it. I'm going to connect it all for you in just a moment here. I got a nice picture and a nice story narrative of what happens with beta amyloid. It can contain iron, copper, and aluminum. Yeah, we know if you have increased aluminum in your drinking water, you got increased risk of getting Alzheimer's, or just call it dementia. I like the word dementia better than Alzheimer's. I think Alzheimer's tricks people into thinking the wrong way. You say dementia, that makes sense. Okay, excess iron overload. You can be copper overloaded as well. You got to watch out for those things. All kinds of sources of heavy metals. Fortified foods with too much iron in them, aluminum in the drinking water, aluminum in deodorants, all those sorts of things. The brain's the most hypermetabolic tissue in the body. So, we always talk about the heart, but you really want to make sure the brain has the energy delivery that it needs. Brain cells that don't get enough energy delivery, they die, go into apoptosis. Another key point is a lot of research has been done in the eye, and the eye predicts the brain. So vascular problems quite often show up in the eye, years, decades before they show up in the brain. So, I see tons of old people, and they're going for cataract surgery. They think it's no big deal. Well, I can tell you this, whenever I look at demented brains, they almost always have at least one cataract surgery. It's a stepping stone. And don't get me wrong, cataracts can happen for other reasons than standard old vascular disease. But what I'm saying is, when a person's got glaucoma, cataract disease, macular degeneration, age-related hypertensive retinopathy, diabetic retinopathy, those are signs that they're losing brain cells and they're going to be presenting with dementia soon enough. So they should really try to get that under control before it damages the brain. Because the brain, a lot of times, you'll lose, let's say, 70% of neurons with Parkinson's, and then it's like you fall off a cliff. You're screwed. Okay, so what you want to do is slow it down as much as you can. You can't completely stop aging, but you can slow it down a tremendous amount. Like I said, look at Okinawans in their hundreds, still with everything functional and intact. Okay, and then here's another thing, too. Everybody's probably heard, a lot of times men have 3 millimeter diameter coronary arteries and a 1.5 millimeter pudendal artery going to the Johnson, so they're more likely to get partial impotence before they get symptomatic coronary artery disease. And the point I'm making is, what the Johnson is to the heart as a warning sign that you're developing coronary artery disease, the eyes are a warning sign to the brain. And I'll also tell you something. Look at Dr. Esselstyn. He's got the best results in the world for preventing coronary artery disease. And sort of like, what's the difference between him and me? I think he deserves a Nobel Prize. He'll never get one, though. And there's no money in this diet stuff. The money's for stenting and open heart surgery. But Esselstyn did a fantastic service to humanity, okay? But there's a difference between Esselstyn and me. I'm interested especially in protecting the brain. All these lectures are trying to figure out how to connect everything and make sense out of everything in the brain. So the brain's more fussy than the heart. It needs even better blood supply, better glucose delivery than the heart does. And it's more sensitive to stimulants than the heart does. The heart, you either infarct it or you don't. Versus the brain, you're kind of losing neurons and you don't see it until it might be too late and you're cognitively impaired in a severe way. Basically like Socrates and Aristotle said, we need to learn what's good for us so we can do what's good for us, and we need to know what's bad for us so we can avoid what's bad for us. And that's what it comes down to. And so all these things, they all add up. The other thing too is some people say, oh, why am I such a stickler for low fat and avoiding oil, not one drop? It's because it doesn't take a lot to tip you over the edge, and we might all have vulnerabilities in our anatomy and our genetic enzyme systems. So you want to only do the good stuff and avoid the bad stuff. Any individual can do what they want. Also, I have high standards. My job is, intellectually to try to be 99.9 percentile. I don't care about middle of the pack. If you want to be in the middle of the pack like a herd animal, go ahead. I don't care, but don't expect me to tell you that I think it's okay to eat a little bit of oil or any of that. No, I agree with Esselstyn. Not one drop. Meat, not one bite, okay? I'm pursuing excellence, the best possible that I could do, and that I'll give the best possible advice I can to persons who want to hear what I have to say, but I have zero interest in moderation or mediocrity. I can't stand that, okay? I can't stand all day long. I just see these fat, sick, cognitively impaired people, and, that's what you should be afraid of. You don't want to end up like that, and it's very easy. Most people end up like that. Okay, 65% of Alzheimer patients are female. Why so many more females than men? Because the guys are already dead usually from coronary artery disease. Okay, some more thoughts on dementia. The main thing that kills everybody is this hypertension, diabetes, and coronary artery disease. And that's actually great news because those are totally preventable. What else? Most dementia is vascular dementia, and all this amyloid stuff fits in there. We talked about the leaky gut component, the Douglas Kell work in a recent lecture. Dennis Burkitt also points out, a good sentence from him was that no animal other than modern man eats more sodium than potassium. You eat plant foods, you're going to get more potassium by far than sodium. Then you hear about the ApoE risk factors for Alzheimer's. And, if you got from one parent, you got a 30% increased risk. From two parents, you got a 60% increased risk. But all this diet and lifestyle stuff is more important than that. Dr. Neil Bernard's pointed that out multiple times. The researchers at Rush University in Chicago have pointed that out. The Katie study in Finland has pointed that out. So you could also have presenilin genes, which increase your risk of early onset Alzheimer's. And that's kind of my point, too. You don't know if you got those presenilin genes. You don't know if you got those vascular variants like I showed in a recent lecture, bilateral persistent fetal posterior communicating arteries leading to bilateral persistent fetal type posterior cerebral arteries, meaning that you have hypoplasia of the vertebral basilar artery system, meaning that you have increased risk of a brainstem infarct. So why not play it safe and optimize diet and lifestyle to reduce those risks of atherosclerosis and having a stroke in your brainstem? Other things that come up, the enzyme that degrades insulin in the blood, insulin-degrading enzyme, also helps to degrade beta amyloid. It's produced in limited quantities. So if it's tied up with insulin resistance, it has to remove more insulin from the blood. There's less of it available to remove beta amyloid. So that's one point. So basically just avoid insulin resistance, which means reduce dietary fat primarily. That's the main reason for insulin resistance. Okay, the amyloid precursor protein, you'll see a lot of pictures of this. It sticks up over the membrane and it gets cut. And then when it gets cut, you can remember T for 2 parts is trophic, that's good. But if it gets cut into 4 parts, your F for FUCD, you're screwed with that. And that's your beta amyloid 42 protein. Starts out as an alpha helix, and then it gets flattened out to become flat like a beta sheet. They all stack up. And you get these insoluble polymers. I'll show you a picture. But the reason why these insoluble aggregates are interesting is they can propagate by pushing on things, and that can cause the adjacent amyloid to also precipitate and form these initially oligomers. That means a few of them all stuck together, and then these big polymers of stacked aggregates. They have to go in the beta sheet to be flat to stack up like pieces of paper. When they're round alpha helices, they don't stack very well. We talked about because the hydrogen bonds are within there holding the thing together versus they're in between the two things sticking them together. But the stacking together and becoming insoluble provides a mechanism by which a prion can propagate itself. It can propagate itself by pushing on adjacent proteins and causing them to precipitate. And that, like a bunch of dominoes, can pass all the way down around the brain. It also provides a mechanism for excitotoxicity. Actually just the oligomers. I'm going to show you a picture of how they can do it. It's been shown that they do it. They intercalate into the plasma membrane of the neuron adjacent to the NMDA receptors, and that will distort the receptor shape, causing it to open up and allow calcium to enter the cell. When the calcium is allowed to enter the cell, I'm going to show you a picture of this in just one sec. That will cause Cytoplasm calcium overload causes hyperactivation of the neuron to fire action potentials, depletes the neuron's energy source. Calcium accumulates in the cytoplasm, then in the mitochondria, and that causes the mitochondria to activate apoptosis. So what's the point of all that? Excitotoxicity. It's the biggest, most important thing I think you could know about the brain. And it's not even in the neurology textbooks. There'll be one paragraph in a 1,700-page neurology textbook in the context of epilepsy or stroke. It's a big joke, okay? Those textbooks are a joke. They're an embarrassment. Okay, so here's just a picture. We talked about this in the lecture about leaky gut, the work of Douglas, Kell, and Etheresia, Pretorius, how with leaky gut you can get LPS into the blood, bacteria into the blood. The LPS is prothrombotic. The bacteria go dormant, but they can be reactivated in the context of excessive free iron. But here's what I think what was most relevant. We're just talking about this. Here's the alpha helices, loop to loop, and here's the hydrogen bonds stabilizing the alpha helices. They're intramolecular, meaning that they're within the molecule itself, versus prothrombotic environment and excess free ions leading to reactive oxygen oxidative stress. The point being is these can distort the shape of, this is an amyloid protein, for example, beta amyloid protein, beta amyloid 42 amino acid length protein, and it will distort them so they now start forming these flat beta pleated sheets. And now you can see the hydrogen bonds are between the molecules, so they're intermolecular, between. And then this big beta pleated sheet will push on stuff. It'll push on the NMDA receptor to allow calcium into the cell. It'll push on other alpha helices of beta amyloid proteins and cause them to precipitate and become solid and do the same thing. So that's a propagating mechanism of a prion. It's a real important point in neurobiology. All right, so here's a cool picture. I was reading these articles trying to get all these mechanisms clear, the biochemistry of it. And here's what happens with these oligomers. So these are oligomers of beta amyloid 42. Most articles will call them, like here it is from this article, they'll call them A beta oligomers. But I like BAP, beta amyloid protein, BAP. Okay, so beta amyloid proteins will form oligomers, so several of them all stuck together, and they can intercalate into the outer layer, the outer face of the plasma membrane of the neuron. And this, it'd be better if they drew it a little closer. This will distort the shape of the NMDA receptor. These are the glutamate neurotransmitter receptors, and that will then allow calcium, these little red dots are calcium, to pass from outside the neuron to the inside of the neuron, into the cytoplasm. And that excessive influx of calcium happening when it shouldn't be happening activates the postsynaptic neuron to then fire action potentials, which requires tons of energy, and the calcium's too high. It'll try to sequester the energy, it'll try to pump out the energy, and because so much calcium has gotten in, because this is an unnatural prolonged opening of the NMDA channel, the cell will become overwhelmed. And when a cell becomes overwhelmed, it tries to store some extra calcium in its mitochondria, then the mitochondria fails. When the mitochondria fails, the cell can't make energy. It knows it's dead. It tries to die by apoptosis. So its molecules, which are valuable, can be recycled rather than stroking, which would cause lysis of the plasma membrane and a big inflammatory reaction. So programmed cell death by apoptosis is a way a neuron that realizes it's slowly dying can recycle itself for the good of the entire brain, if you will, rather than, going to a full-blown lysis where its plasma membrane is lysed and then there's a big inflammatory reaction and its molecules are distorted and destroyed and not salvageable. So anyways, this is actually a really cool concept here. If you're interested in excitotoxicity and prion mechanisms, and here's the paper right here from this journal showing how the oligomers of beta amyloid intercalate into the plasma membrane of a neuron and cause distortion of it such that it causes distortion in the NMDA receptor, leading to increased calcium influx. This is a really cool thing, connection of prion mechanisms to excitotoxicity. And we also talked about leaky gut being connected to precipitation of these prions. So this is cool stuff, how prions propagate, how prions can activate a receptor, how prothrombotic blood and iron excess can lead to prion activation with subsequent excitotoxicity. And bottom line, you eat the healthy diet and you avoid all the processed food, and the other things on that list, my previous lecture checklist of leaky gut causes, you avoid leaky gut. You avoid this stuff. Here's just some good papers. So if you want to see the scientific research papers going over these mechanisms, these 3 papers are good. Okay, amyloid beta oligomers activate NMDA receptors, like we were just talking about. Nice paper here, sort of the same thing, but in more detail. And it also talked about the LPS activation of a toll-like receptor, which is another mechanism. These are all converging on excitotoxicity. So I brought up this LPS activation because that came up in my last lecture when I went through the work of Douglas Kell and Etheresia Pretorius with regard to leaky gut association with iron overload, reactive oxygen, oxidative stress, and subsequent activation of this Prion mechanism to cause dementia. And then here's another paper, same type of stuff about how beta amyloid protein oligomers can activate NMDA receptors and the mechanical pressure itself. The mechanical pressure, that's why a protein, you think a stupid dead protein, how could it cause any trouble? Well, it can. When they get big and they precipitate and push on things. Will activate NMDA receptors, influx of calcium, cell's dead from apoptosis, and they can propagate it straight along as well. That might be, let me see if there's one more slide. Okay, here's one more slide. I think this is the last slide. So we talked about anything that increases atherosclerosis is going to increase risk of dementia, and the atherosclerosis vascular stuff's a much bigger deal than the APO. If you fix all your atherosclerosis risk factors, your APO4, if you got them both even, it probably won't cause you any trouble. Interesting things too. The same countries that got a lot of atherosclerosis, coronary artery disease, where it's their number 1 cause of death, like United States, Canada, and Finland, they're the same country with tons of Alzheimer's. And if you separate all the cancers into individual cancers, then dementia is a more common cause of death than cancer. You know, some might debate that with lung cancer, but I think you get the point. Dementia is a super common cause of death. It's kind of like being demented. You know, being demented is kind of like being dead. You no longer can remember anything or recognize people. That's, you know, your life's pretty much over at that point. But this is an interesting statement. It's the same countries that got tons of atherosclerosis where coronary artery disease, myocardial infarction is the number 1 cause of death, are the same ones that have off the charts number 2 cause of death, dementia. That's interesting. And United States, Canada, and Finland are good examples. They all eat high fat, a lot of meat, and the United States eats tons of oil as well. It's terrible. And lung cancer is a lot more common in the United States, where they had all these high cholesterols compared to countries that smoked a lot like Japan and Papua New Guinea because they didn't have high cholesterol. You know, I'm talking about back in the 1970s, for example. It's a good idea. Is it a good idea to remove amalgam dental fillings because they got mercury in them? They kind of could call them mercury fillings. I don't know. There's biologic dentists that do the procedure, but the most toxic they are is when they first go in and then when they come out. So is it maybe best to just leave them in? I have known people who had a lot of them and who left them in and they actually did fine. That wasn't their problem. But, you know, the answer to that, I don't know. That'd be something maybe I'd like to learn about in the future. Okay, I see lots of crazy stuff on the internet, recommendations for patients to prevent Alzheimer's or that have chronic traumatic encephalopathy from chronic head trauma, and they get recommended fish. Stupid. Fish is a bad idea. Tons of mercury, PCBs, EDC, sat fat. You know, as soon as somebody says that, in my opinion, I wouldn't listen to their advice anymore about nutrition. They don't know what they're talking about. And then they're going to say, well, you know, salmon's okay, but tuna's bad. No, fish is bad. Forget about fish, okay? You're not going to win anything with fish. Olive oil, bad idea. Olive oil gets all this publicity and stuff it doesn't deserve. Stay away from that stuff. It's a highly processed food. Make you fat and sick and atherogenic. Ketogenic diet, complete stupidity. Why give yourself an atherosclerosis diet when atherosclerosis is the big thing, you know, associated with dementia? Most dementia, I believe, is vascular for numerous reasons I've talked about in previous lectures. I don't like taking omega-3s because I did a whole lecture on why I think they're a bad idea, but especially lipid peroxidation, and you don't need that many. The brain cells don't turn over that fast. You got the same brain neurons since you were a kid, remembering your childhood memories. Mediterranean diet with all the cheese wine, it's just stupid. It's a bad idea. That's all just like a lazy, ignorant person says Mediterranean diet. That's a major red flag. Person's lazy, doesn't know what they're talking about, ignoramus, when they start recommending the Mediterranean diet. You know, I sort of like, oh, wasting my time listening to this person. Okay, key points. Dementia causation is multifactorial, and you should try to optimize everything because there's going to be some things you can't fix. There's going to be maybe a genetic component you don't even know about, a vascular variation you don't know about. So diet should be, oh yeah, somebody else told me that I should say my diet is very low fat. Yeah, about as low fat as I can get it. Dr. McDougall says if somebody closely follows his diet, they should only be eating 7%, about 7% fat. You follow Esselstyn's diet closely, probably end up in the ballpark around 8 to 10 percent fat. I haven't calculated it for mine, but it's going to be, in probably right around McDougall's or lower, but it's in that ballpark. Kempner had it really low. One article I read was as low as 2%, but I don't remember exactly off the top of my head what Kempner's was, but I know it was right around there. I talked about it in my previous lecture. It's down in that ballpark. Rice was the main source of calories, really low in fat and protein. We talked about sleep, super important, lymphatic system. Exercise does tons of good things for the brain. There's more brain resources dedicated to exercise than anything else. Social support, get along with people, so you keep that in your life. Have a sense of purpose, helping others is good. Have a sense of religion. All these things lower your stress level, so they lower your cortisol level, which means you lower your hippocampal glutamate, which means you lower your metabolic demand in your neurons, and your brain works better. It makes you more resilient. Kind of like the Serenity Prayer. Help me to handle the things I have to handle and not make things worse than they already are. Having religion helps a lot of people. The healthiest people in the world tend to be religious, like the Seventh-day Adventists are the longest lived documented population ever in the history of the world. So a lot of people make fun of religion, but you know what? The religious people outlive them and they're healthier. So there's something good to be said for that. Anyways, I hope this was helpful. I think that's it. Yep, pretty sure it is. Yep, that's it. Okay, hope it was helpful.